I am Suraj Soni, an author of ChemSTAR. So, friends, you are watching my YouTube channel ChemSTAR. On this channel, you will get all the previous year questions with quick and tricky solutions. So, in today's session, I am going to discuss with you a question asked in net set and get examinations. So these questions are from previous year question papers, and basically these questions are from an atomic term symbol concept. So watch this video. If understood, please like the video and share with your friends, and don't forget to comment. So let's start for today's session. Friends, let's start for today's session. So as you can see on the screen, it is written here atomic term symbol, right? So here you can see the questions. Let's see what is the question. So the question is, find the atomic terms for the following. All right, so in this video I have discussed randomly an element from the periodic table. So this may be in your question paper in the next year. So let's see how we can find out the atomic terms for the following elements. All right, so from this video you come to know how you can find out the atomic terms of a given element. All right, this video is going to give you a basic idea about how you can find out an atomic term symbol. All right, so let's see one by one. So before starting solving the questions, let's see the basic concept first, so that you can do it very quickly, so that you understood this concept very quickly. All right, so the basic formula for finding out an atomic term are, let's see, here we can say here the formula is 2s plus 1 L and J. All right, so this is a basic formula for finding out an atomic term symbol. Okay, so 2s plus 1 Lj, that means if you calculate 2s plus 1 Lj, that means you are finding out atomic term symbol as a whole. All right, as I said, now if you are finding out the value of 2s plus 1 L and J, if you are trying to find out the value of this whole, that means you are finding out atomic term symbol. Okay, but here you can see in the question, they have asked only atomic terms. Here I am underlining this. They said to find out only atomic terms, not atomic term symbol. If they will tell you to find out an atomic term symbol as a whole, that means you have to find out the value of all these 2s plus 1 L and J. But in this question they ask you to find out atomic terms only, that means you have to find out only this 2s plus 1 L, not J. If they will ask you to find out atomic term symbol whole, then you have to calculate J, otherwise you have to calculate only 2s plus 1 L. All right, so let's see the solution of this question. Let's see one by one each elements. So first element is helium. All right, as you know, helium atom has atomic number 2. All right, it is second element of the periodic table, that means it has atomic number 2. All right, if we see the electronic configuration of helium, then it is 1s2. all right, if we see the electron distribution in the s cell, so here you can see 2 electrons are here. So we can arrange 2 electrons by Hund's rule, which is like this. all right. So here we can take 0 and so here 0, that means this value is the value of L, all right. So here L equals to 0. What I am writing on the top is here 0. I have written here 0. This is the value of L, okay. So in case of S cell only one cell is, in case of S cell only one cell is there, so that here only 0 is here, alright. If it is P cell, just assume, okay, if it is P cell, that means it has 3 orbitals. So here we can say 0 plus 1 and minus 1, but here only S cell is there, so we will take here 0. So here L, value of L is 0, alright. So here you can see here one is upward spin and one is downward spin. That means spins are opposite each other, that means there is no spin, alright. So here S is also 0, alright. So here if we see, if we try to find out the value of 2s plus 1, then we will get, let's put it in 2s plus 1, 2s plus 1 equals to what we will get, 2 into s ka value is 0 here, so 2 into 0 plus 1 equals to nothing but 1. Here we are getting spin multiplicity. 2s plus 1 is nothing but spin multiplicity, only s is spin. So here we have got spin multiplicity as 1, alright. So we can write here atomic term of helium as, so let's write atomic term of helium is nothing but, here formula is 2s plus 1 L for atomic term, alright. Here you can see the formula 2s plus 1 L is for atomic term. So here we have got the value of 2s plus 1 here, which is nothing but 1, and we have value of L here also. So as we know, if you have not seen my previous video on the same topic, you can visit the channel, my channel ChemSTAR. You will find the basic concept of this particular video. So let's explain, I will explain you once again. So if you are getting the value of L as a 0, that means here your atomic term will be S, alright. If you are getting the value of L as 1, then your atomic term will be P, and if you have a value of L as a 2, then you will take atomic term as a D, and last is if you have the value of L is 3, then atomic term will be F, alright. So here in first case, that means for helium atom we have an L value of, we have value of L, here you can see value of L is 0, alright. So here we can take for 0 atomic term will be S, alright. So here we can write S at place of L in this particular formula, and at the place of 2s plus 1 we have here 1, alright. So we can write here 1, alright. So this is a atomic term for a helium atom, alright. So helium atom ka atomic term will be 1s. So let's see the next element. I hope you are understanding what I am trying to say you. So the next element is nitrogen, alright. Nitrogen has atomic number 7, okay. So electronic configuration will be 1s2, 2s2 and 2p. 2 plus 2 4 plus 3 is 7, alright. So here this is an electronic configuration of nitrogen atom. So if we here, as we can draw here cell for this S and this S and this P, alright. So here for S, no mean to write the electron distribution, because this S cell and this S cell is completely filled, so they are not of our interest. So I am not going to write here for electron distribution, so I will write only for this, for 2p3. all right, so concentrate here. So for 2p3, here 3 electrons are there, here 3 electrons are here. So I am going to distribute these 3 electrons according to Hund's rule. According to Hund's rule, Hunt says first you have to fill half, that means you have to fill 1 electrons in each subcell, and if it's still left with you, then you can fill it double. all right, so here we have 3 electrons, so we will fill according to Hund's rule 1 electron here, 1 electron here, and 1 electron here. all right, so here, as I said, let's write here. Here is no space, so I am writing it here again. So this is all right, so here 0, here is +1, here is -1. all right, so for this electron spin is half, for this also spin is half, and for this also spin is half. all right, so these 3 subcells are half filled, so for each subcell spin is half. all right, so let's write the value of L here first. So here as I said, what I am writing at top of the electron distribution is the value of L. all right, so here plus L minus +1 -1. If we add +1 -1, we will get 0. all right, so here L value will be 0 again. So here let's see what will be the value of S. So plus half plus half is nothing but 3/2. all right, so here the value of S is 3/2 and the value of L is 0. And as I said, if you have value of L as 0, then your atomic term will be S. all right, here you can see, then your atomic term will be S. So I am writing here atomic term. For nitrogen is nothing but, atomic term for nitrogen is nothing but, here value of L is 0. that means we have atomic term S, and here we have S ka value is 3/2. so let's find out the spin multiplicity for the nitrogen. So for formula for spin multiplicity is 2s plus 1. all right, so when we will solve this, we will get 2 into 3/2 plus 1. all right, so this 2 and this 2 will be cancelled, and this 3 plus 1 is nothing but 4. okay, so here spin multiplicity is 4, as you can see here. Just try to understand what I am saying. all right, so here the spin multiplicity is 4, so we have to write it here as a 4, because let's remind, because the formula is 2s plus 1 L. all right, so at the place of 2s plus L, here I have written the value of 2s plus 1. so the atomic term for nitrogen will be 4s, or you can say S4. all right, so let's find out for next third element. So here you can see third element is vanadium 3 plus. all right, let's take it here. So third element is vanadium 3 plus. So vanadium atomic number of vanadium is scandium 21, titanium 22, vanadium 23. all right, so atomic term for vanadium is 23. all right, and here you can see vanadium has +3 charge. that means it has donated 3 electrons, so that's why it has +3 charge. all right, so while writing the electronic configuration, we will write electronic configuration for only 20. All right, because it has donated 3 electrons. So out of 23 it has donated 3, so we have 20 now. So we have to write electronic configuration for only 20. All right, so let's write the electronic configuration for vanadium 3 plus. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 3d. Let's count the electron first. 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12 and 12 plus 6 is 18. all right, so here we have to write for 20. So here 18 is already completed, so 2 is left, so here 3d 2. okay, all right, so this is completely filled, this is also completely filled. This p S cell has a capacity of 2 electrons, that's why I'm saying it is completely filled. all right, and P cell has a capacity of only 6 electrons, so I am saying it is completely filled. So that means I am not going to write anything, or I am not going to discuss about fully filled cells. Only here you can see 3D is not completely filled cell, so I am going to write for this D. D has a capacity of 10 electrons, but here D has only 2 electrons, that's why it is R, that's why it is for our interest. okay, so D cell is divided into 5 subcells. all right, so 1 2 3 4 and 5. all right, so here middle one will be 0, and here this will be plus 1 and this will be plus 2. Here this will be minus 1 and this will be minus 2. This is the value of L. all right, as I said before. So this is the value of L. So let's see, here only 2 electrons are there, so let's fill it according to Hund's rule. So according to Hund's rule, we have to fill only 1 electrons in each subcell. If all subcells are half filled, then we can fill it doubly. okay, then we can fill it with 1 more electrons. So here the value of L will be here plus 2 and plus 2 and plus 1 is plus 3. all right, and minus is plus. all right, so minus 1 and minus 2 will be minus 3, but this is not of our interest because only these 2 subcells are filled, so this is of our interest. okay, so we will add this, so plus 2 and plus 3 will be plus 3. So here we have value of L as 3. all right, and here you can see 2 subcells are half filled, so for 2 half filled subcells we will get the value of S as half plus half. all right, which is nothing but 2 by 2, which is nothing but 1. correct, so here we have value of S as 1. so let's find out the spin multiplicity first. So formula of spin multiplicity is 2s plus 1. So we will put the value of s as 1 here, then we will get 2 into 1 plus 1. 2 into 1 plus 1 is nothing but 3. okay, so here we have spin multiplicity is 3 and value of L as 3. So atomic term for vanadium 3 plus will be we have a value of L as 3. so as I said, if you have L value as 3, you can see here I am underlining, if you have L value as a 3, then you will get a term as F. all right, so here we have term F. correct, so and spin multiplicity is 3, so we will simply write it here 3. all right, so this is atomic term for vanadium 3 plus. all right, so last 4th element is fluorine. all right, I am giving you a hint for fluorine. So fluorine has atomic number 9, so simply you can write electronic configuration for this, and as discussed for 3 elements, likewise you can solve for fluorine also. So this is a homework, you can take it as a homework and solve this. If you are finding out the answer of this, then it is good, and if you are not finding out the correct answer of this, then you can comment me, I will solve this also. So thank you very much for watching this video, I hope you understood. Thank you very much once again.